With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states that a cube of wood of mass 0.5 kg. So we have this wood of mass 0.5 kg and the density 800 kg per meter cube is fastened to a free end of a vertical spring of a spring constant K is equals to 50 Newton per meter. So this wood is fastened with this spring fixed at the bottom. Now the entire system is completely submerged in water. So we have submerged this system in water, right? The elongation or the compression of the spring in equilibrium is beta divided by 2 centimeter. Then we have to find the value of beta. Now let us first try to understand whether there will be elongation or compression. So very easily we can understand that since this is wood and it has density 800 kg per meter cube and this is water, so water simply have density equals to 1000 kg per meter cube, right? So you see that the density of wood is less than the density of the water, so this should float. Now let us first try to calculate the buoyant force on this and its weight. For that first we need to calculate the volume, right? So how do we calculate the volume? We have been given the density of this wood or the solid is simply equals to mass divided by volume. Now from here we can calculate the volume simply 0.5 divided by 800 meter cube. So from here we get the volume of this wooden block is simply 6.25 into 10 raised to the power minus 4 meter cube. So this is the volume. Now let's try to find out the weight. So we can see that what is the net downward force on this. So the net force will be equals to first is weight. So let us try to calculate its weights. So its weight is simply m times g, mass into g. So mass is 0.5 into g is 10. So its weight is simply 5 Newton. And since it is immersed in a liquid, so we have found out the weight, right? Now let us try to calculate the buoyant force, right? So let us try to calculate the buoyant force. So buoyant force is simply equals to density of the liquid times the volume of the solid times g. Volume submerged, but here you can see that the entire block is submerged in the water, so we will take the entire volume. So this is 10 raised to the power 3 because this is water. Volume submerged is 6.25 into 10 raised to the power minus 4, and if we take g as 10, so what we get 6.25 Newton. Now very clearly you can see that since the buoyant force is greater than the weight, so there will be elongation. Why? Because the upward force is more, so this upward force will try to bring this block in the upward direction, so the spring will be stretched, and when the spring is stretched, then the spring force will simply act in the downward direction. So this will be the spring force. Let us take that as Fs. So if we apply the equilibrium, right, so what will happen in that condition? Fs, since Fs will act downward. Why? Because the spring is elongated, so the spring force will be acting downward, right? Spring will be trying to push this backward. So spring force plus weight has to be equals to the buoyant force. No, now from here what we get a spring force is simply equals to the difference of buoyant force and weight, 6.25 minus 5 newtons, and then we can write in place of spring force as kx is equals to 1.25. So from here when we solve for x, what we get x equals to 2.5 centimeter. We have been given the value of k in the question. K is 50. So when we solve and convert that into centimeter, we get 2.5 centimeter. But this is not the final answer. We have to find the answer in terms of beta by 2. So we can write this as 5 divided by 2 centimeter. So now this is written in the form beta divided by 2. So you can see that the value of beta is simply equals to 5. So this is the final answer, right? So I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.